Hi, welcome to Fun at Pi videos. This is DC here. This is the third video on access rights used in AT88SC153 secure memory card. In this video, I'm going to cover the remaining bits of access rights and also give you some information about how the authentication works in this secure memory card. So I've got both good and bad news about authentication. So the bad news is you cannot authenticate using the software, and the good news is there are some hardware based solutions manufactured by the microchip which you have to use for authentication. You can see here the version of this software is 1.9.3. a small change has gone into the screen restructuring as well, especially a new section has been added called authentication. So keep in mind this section does not work. We have got this to show you that it doesn't work. So that's the thing we're going to cover here. So up to the last videos we have covered so much of information on how the access rights works. Especially we covered most of these bits, and there are a few more bits which is available under the identification section. This is called as a device configuration register. Now if you ignore these 4 bits, this is something to do with the hardware side of this memory card, so which I think is not used or is not going to affect when using this card with the ACR 38U. I'm going to discuss about these 2 bits here, which is called 8 trials allowed and unlimited authentication trial. The 8 trials allowed is something to do with the number of times we are allowed to do the wrong passwords. We have seen this in my previous videos. By default this secure memory card allows you to make only 4 mistakes. After that that particular password gets locked. So what I mean here is I'm going to verify. If you just keep an eye on this, I'm going to verify with the wrong password, and you can see here the password access counter has started to reduce here. Now even though there are 8 bits, only the 4 attempts are allowed. Now you have a replica of these 4 bits. Now I have made a wrong password attempt once, so the first bit is gone to 0. I'm going to try second time. It's again we have lost twice, and you know that this 4 bits repeats in the next lower byte as well. I'm going to enter the correct password, which I know it's FF. Verify, then you got this password attempt reset back to once. Now I'm going to make change for these settings. Now I'm going to untick this or set this bit to 0 to have 8 password attempts. Now in order to make changes to this this section of the memory, I must use or verify the secure code or the transport code, which I'm going to do here. Now once you verify with the secure code, you can start reading everything, all the hidden part of this memory. I can read issuer code, the crypto, or if you go to the secret code, I can read that as well. If you go back to this, I'm going to remove and write. Now what we have just made is we have told this secure memory card to allow 8 wrong passwords. So if you read this again, you should see that now this bit is set to 0. Now I'm going to select, and this we know that it powers down and powers on again. Go to the password and try authenticating using wrong password. Verify. If you look at that, now this entire 8 bits are available to count the wrong number of password attempts. It is the first attempt is gone, so it is set to 0. Keep on verifying, so you can go up to 7. Now you can enter the right password, so it'll go back to 8. Okay, that's what this bit does. So I'm not sure about unlimited checksum rates as of now. Probably once we do more reading, I'll make a new video on that. Now, supervisory mode enable, the documentation says this will be useful only when the tag is working at the personalization level, which I'm going to cover in my later videos. If you look at this, the authentication, now you cannot authenticate using the software. You must have a hardware which is supplied by the manufacturer to do the authentication. I'm going to give a brief idea about how the authentication works, and I've picked up this information by reading the documentation on this, as well as some documentation on the crypto memory. If you have used some contactless cards or any card that use a standard cipher like a 3DS or a AES or a DES algorithms, this is how the authentication would work. You got two sides here, the card and the host. They both share the key. So in other words, the key is stored in the card, as well as even the host knows the key. And there are so many ways to get this key, and it's also documented or published that what type of a cipher is used in the card. So assume that it is either DES, 3DS or AES. So we know what algorithm is used to encrypt or decrypt. So what the host does is, it generates a random number using the key, and using this known cipher is either AES, it generates a challenge, some kind of a encrypted number. Now the card also does the same thing. It uses the random number of the key. It uses the key stored in the card. It uses the same algorithm. Whatever, if it's AES is used here, the AES also used here. This also generates some result. I'm going to call this as challenge. Now if the keys were the same, these two values must match. Now when they match, we say that authentication is successful. Now this is just an overview of how this kind of mutual authentication works. But if you want to go in detail, you would ask questions like, how is the random number from the host is passed to the card, or is it the card produces a random number and sends it here. Now there are so many things, but this is just a general idea about how the authentication would work. So here the highlights of this concept here is, both the card and the host, they store the same key, and both generates some challenges, some output using the keys and using the same input or random number. When they both match, the authentication is successful. So this is how the authentication is done using the secure memory cards, and I got this information by reading the data sheets, and if you read some of the data sheets of crypto memory, you understand. Now the difference between this and the one I discussed before is, this algorithm is not known, it's not available to the public domain. So this is a proprietary algorithm, and for that reason I mentioned that you cannot use a software for mutual authentication. Now one way it's good, because if there is a hardware available for generating these type of the keys, it is going to be faster. The way this authentication works is, Again the same, the host and the card and the host, they share the same key, or they know the keys. In this secure memory card, it is referred to as a secret seed, or which is called a GC. So the GC is known for host and the card. So in this algorithm, the value of the cryptogram is also used. If you recall the memory structure of this secure memory, there is a 7-byte number called a cryptogram that's also used here. So the host will first read the cryptogram, and it uses the secret seed, and it generates a random number. Using this algorithm, it generates a challenge. What the host does next is it is going to pass the random number to the card. Now the card will use this host random number. It uses the cryptogram which is stored in the card, which will also use the secret seed. It generates a challenge. Now if the secret seed CI, if they match, we will end up getting the same challenge. So when these two matches, we say the authentication is successful. Now whenever the authentication fails, there is a authentication counter which is called ACC, which by default you will get 4 attempts. So for every authentication, wrong authentication, this will start becoming zeros. When it becomes all 4 zeros, that you cannot do any more authentication. However, you can make it go up to 8, just like we saw how to make the password count set to 8. So this is also valid. Now this is a bit of it's a different way. Probably now I will try to put this in some other way. So what the host first does is it reads the cryptogram from the card. The cryptogram is always readable. The host knows the password or the secret seed. Usually these type of keys are generated by the identification number which is stored in the card or assigned to the card. This is called as a key diversification. The host generates a random number. So the host will compute its challenge. Now the host is going to send its random number, its challenge to the card. The card will carry on the same operation. It will use the same random number from the host. It uses the cryptogram, uses the seed. It generates its own challenge. If these two challenge match, it will set the access counter to FFs. Now this indicates that the authentication is successful. The host should check the value of this AAC in order to determine whether the authentication is success or not. So what we need now is the command to send to tell the card that this is the random number, and also a command to tell the card that this is the challenge. Then the card will tell whether it's success or failure. Now if you look at the documentation of ACR38U, there are 2 commands which are used for the authentication. I'm going to show that now. The first command is called initialize authentication. This is the command you're going to use to send the host random number to the card. After that, there's a command called verify authentication. This is the command the host is going to use to send its challenge. And here the documentation is not complete. When you send this verify authentication command, you will get an output which is FF it's successful, or any other number that indicates the current value of the AAC, that is how many attempts you are left. So I'm going to show this authentication using the card. So back in the software, if you go to the authentication section, so the first text box is where you generate a random number. I provided a small shortcut here. If you click this generates a random number, and here you're going to enter the host challenge bytes. So assume that you have a hardware from microchip that will produce the challenge. So probably you can copy and paste that number here. I'm going to hit verify. If you look at the commands, sorry, before I should have done the initialize here. Now set initialize and give verify. So if you look at the value, so the verify command, so the initialize command is used to send the random number to the card, and the verify command is used to send the computed challenge of the host to the card. Now we know that the card will use this random number, it generates the challenge, and the challenge should match with what the host has sent. So because we know, we are 100% sure this is not the correct challenge, the card is telling here that authentication has failed with the value FA. If you go to this section here, identification section, you got the AAC. If you look at here underneath, you also have the cryptogram. This is what the card will be using, and the value of the cryptogram is always readable, as well as the secret key. This is not readable at all. If you go and hit the read here, now this is in the reverse order. Probably I have to fix this. Now one of the attempt has been used. If you verify again, so sorry, I think every time you have to first send initialize, verify. Now you got FC. If you go to here, you can see that 2 attempts have gone. So likewise, if you go and hit initialize and change something else, verify, we got, so the 3 attempts have gone. So likewise you can go up to 8. Now I'm sure is letting us to go up to 8 because of this 8 trials allowed. Now this controls, the 8 trial allowed controls both the password PAC as well as the authentication AAC. So there's one more option here called unlimited authentication trials. Now this probably means that there is no locking of authentication at all. So I'm still not very sure how this thing works. Probably once I know, I will make a video on that as well. So because the card I'm using here still runs at the fabrication level and I'm using the secure code, I can go back and reset this counter back to zeros. And maybe we are not able to do this when the card is blown to the CMA or personalization. So yeah, sorry, before I do that, I have to first verify using my secure code. Go here, set all to 1, right? If I try to read again, yeah, now we are set back to AA. So that's all about this access rights so far. In my next video, I'm going to show you how to personalize, and we are going to see all the things you can do with the tag after these 2 fuses are blown. Thanks for watching.